Hello everyone, welcome to another video, and in this video we're gonna solve a question called valid anagram. So the question suggests, given two strings s and t, return true if t is an anagram and of s and false otherwise. So a anagram, we can define an anagram that we are given a string, right? And another string should be constructed, can be constructed using the same letters or same characters from this string. So first condition, the length will be same, and the number of characters of same, and the same number of character of individual character that are present in one string should match that of other string as well. So at that time we call the both strings as anagram. So let me discuss this and on whiteboard, right? So let's take this example where we have a s called anagram, right, and another string called t. Let it be NAGARAM. So now you see s and t are anagram because if you see, every character of s is present in t, and the occurrence of characters are also same. The words order can be mismatched, but you can form t using every character of s, and the occurrence also remains the same. For example, n, one occurrence, a, two occurrence, three occurrence, sorry, g, one occurrence, m, one occurrence, r1. So the length will become the same, and the number of the occurrence of characters in both the string are also same. So these two strings are anagram. So how are we going to solve it? See, simple. In one way we're going to solve is that if we sort it, right, then no matter what the string is, if they are same, right, the sort order will become the same, right? If it and the sort order will become a g, something like that, right? M and R, something like that. And if you sort the second one as well, it will also become the same. So you just have to return if s sorted s is equals to sorted t, right, or not, and this will return your answer anyway. So but the worst case scenario here is like OFN square. It depends on what kind of search algorithm you are using. Behind the scene, JavaScript uses merge sort, I believe. So let's consider the best case scenario will be n log n, right? But again, this can be solved with OFN as well. For example, see, we are checking the occurrences. So definitely we're gonna map. See, first of all, if the length are not same, we have to return anyway false, because they can't be anagrams. But the length are same, then we're gonna iterate from left to right up to same length, right? And every time we find a letter, we're gonna create a hash map, and we are keep track of the occurrences. So at the end, a will become 3, right, and n will become 1, g will become 1, and so on, right? So for both the both the strings, we're gonna create our occurrence hash map, and so it will take OFN. Space will be OFN plus OFN, right? Now in third occurrences, again we're gonna iterate through 1, string OFN, and we're going to check the occurrence of same character of that string in others what occurrence of this one with the occurrence of the T as well, the other string. If there is a mismatch, it is false. If both are anagram, by the time we reach to M, all the occurrences of that character will match. So another OFN. So we're going to do two iteration. One is OFN to get our occurrences, and second OFN to match those calculated occurrences. But space wise we need two extra hash map, right, for both the string. So it's OFN plus OFN, we can consider it OFN. So yes, so we're going to solve it using our hash map method because that is the most efficient in this particular case. And let's do it. So let map t1 equals to new map, same as let map t2 equals to new map, right? And return for so we have created two maps. Now we have to iterate through one, right? Let so for I, then we have to any one of those t1.length or t2.length is fine. So we have to have one condition here. If t1.length not equals to t2.length, return false anyway, right? Now here we have to check if t1, if map t1 dot hedge t1, let's first create t1 is equal to t1 dot at I t2 dot char at I. So I created a variable so that we don't have to write get multiple times or this char at I multiple times to get the character. So now hedge char t1, then map t1 dot set, right, char t1 dot map t1 dot get char t1 plus 1, else map t1 dot char t1 1. So we are setting it as 1. Now the same set of code we have to return for map t2. So let's just copy it. So yeah, t2 So same way we're going to check the map T2 head char T2 or map T2, then we're going to we just increment the counter, the occurrence value. If not, we're going to initiate it with char1. So this will create our two maps. In our third one, then what we have to do is we're going to again have to iterate through the same, at least with one at least on one string. So we're gonna create again with t1. Okay, now we have to create the same. We have to get these two values, char and char2 again, so that we can compare the values. So for every I, if, right, map1 map.t1 dot get char t1 not equals to map2 dot get same value, and we have to compare the same character. So again we have to create char t1. We don't have to use char t2 here. One is enough because we have to compare through the same character. So if this does not match, we have to return false. If everything passes, at the end we have to return true. So this should solve our anagram problem. Now let's see. Now let's go to our test, run the test case. What happened? Oh, sorry, syntax issues. Map.set map2.set. Anything else? Get, yeah, fine. This should work. So boom. So that's how we're gonna solve it using a hash map. And yeah, if you don't, you see this also gonna work like return t1 dot sort equals to t2 dot sort. This one line code can solve it, but again this will be like n log n depending upon what language you are using. In JavaScript it should be n log n, but again, what if they ask you again to implement a sort for this? But again, the most efficient way we should follow, the most efficient way is to create a hash map and keep track of the occurrences. So let me comment it, and yeah, that's that. Thank you for watching.